Right, good morning, students. So today we are going to do another video lesson on internal energy. Before I start, I want to ask you which has the most energy. This a hot cup of tea with 90 degrees Celsius or a bathtub of water at about 45 degrees Celsius. Well done. If you come up with the right answer, the bathtub of water contains the most energy. And can you think why? So I will repeat this picture at the end of this lesson, and I hope that you will be able to find out the connection that why a big bathtub of water contains the most energy even at the less temperature, 45 degrees Celsius. So if you have already started thinking on that, well done for this. So the lesson topic is internal energy. This is the bigger picture of our lessons. So we are currently doing lesson number 4 of P6, molecules and matter. So by the end of this lesson, you should be able to define what is meant by internal energy. Also, you should be able to use the idea of kinetic energy and potential energy when discussing the internal energy of the system. I want you to be able to explain what happened to the internal energy in the system when the particles in a system are heated up. So let's talk about the prior knowledge, what we have done in the previous lessons, changes of state. So changes of states depends on the temperature. So remember, when we heat a solid, it may melt and form a liquid, or liquid can change into a gas. And the reason is the thermal heat energy. So when the thermal heat energy is being used to break bonds between the particles during the the change in state happen. Also, if there is a less temperature, when you cools down a liquid, so it changes into when you cool down the gas, it changes into liquid, and when you cools down a liquid, it may freezes and form a solid. So thermal energy is being lost in this case, and they form bonds between the particles during the change in state. It is an important thing. A change of state is a physical change and not a chemical change. This means you do not end up with a new substance. So it's the same substance you started with, but in a different form. For example, water has three states, ice, liquid, and gas, but still the composition of water is same. So if I give you the example of these four particles of solid, so they are tightly packed and in a proper rows. They cannot move around, but they can vibrate about their fixed position. So what might happen to the motion of the particles if they were heated? You can see what's happening. The vibration is increasing. So the four particles absorb the external thermal energy and vibrate a lot faster about their fixed position. So when we talk about the energy stores, the particle in a system vibrate or move around, they have energy in their kinetic energy stores. The faster they move, the greater the kinetic energy store they have. The particles also have energy in their potential energy stores. Potential energy of the particles is due to their positions relative to each other. So there are forces of attraction between particles which must be overcome by putting energy into the system. So as the particles move further apart, their potential energy store will increase and vice versa. Internal energy. So we can say the energy in a system is stored by its particles, atoms and molecules. And the total energy that particles in a system have is equal to the sum of their kinetic and potential energy stored. So we call this total energy the internal energy of the system. So when you heat a system, it will transfer energy to its particles and they will move faster, so they gain energy in their kinetic energy store. And when you increase the kinetic energy, the internal energy of the system will also increase. So this can lead to the two things: change in temperature and change in state. So when the temperature increases, what happens? When the kinetic energy increases, what happens? The change in temperature and change in state as well. So if heating a system results in a change in temperature, the actual size of the change depends upon the following as well. So we can see the temperature change depends on, number one, mass of the substance, its specific heat capacity, and the size of the energy input. So if heating a system results in a change in state, the particle will have enough energy in their kinetic energy stores to break the bonds holding them together. The particles would move slightly further apart, which would causes their potential energy stores to increase. So the kinetic energy and the temperature relationship is like that. When the kinetic energy store increases, then the temperature increases too. And what happened with the potential energy rise? So when the potential energy rises, the particles are moving further apart, and during this, the change of states happens. Okay, so you can pause this video and I want to do your progress check. Just pause this video and answer these questions based on the information what we have seen throughout the PowerPoint. Okay, now you can see the answers. You can mark your answers. You can pause the video and mark your answers. Brilliant. So if you got these colors, if you got red, orange, or green, you can choose the exam questions based on these colors. I will upload these exam questions on Show My Homework, and then you can select the copy of the correct exam question from the Show My Homework. And these are the marking schemes. You can mark your answers according to the exam questions you have chosen. So I come back to this question again. And when we talk about in the start that a bathtub of water at less temperature than a cup of water, then what's the reason behind it? So we can say when there are more number of particles, then they have more heat capacity to absorb it. So their internal energy, as respect to the number of particles, is more than the internal energy of the particles in the cup. Okay, so as the plenary question, I want you to select two numbers between 1 to 25 from the following table and write down these in the margin of your book. So now complete the sentence or question from the number that you have chosen. These questions are based on your own reflection that how much you have understood this lesson or how much you have learned from this. So you can choose any two boxes and you can write down for your own reflection.